This video follows on from the first webinar we conducted on Python, ZeroMQ, and MetaTrader, the integration we discussed therein. It went through everything from the beginning in terms of why ZeroMQ, what it is, the integration possibilities between ZeroMQ and MetaTrader, and how Python fit into the picture. Here, we're continuing on from that conversation in the context of trade execution, management, and reporting using Python. In terms of prerequisites, it would be useful if viewers of this video have some programming experience. That could be in one or more of the following programming languages, these being compliant, all of these being compliant, of course, with ZeroMQ, as in ZeroMQ has bindings for these programming languages: C, C#, C++, Python, R, and MQL, of course, that's required for programming the MetaTrader side of things that we're going to discuss shortly. Trading experience with MetaTrader 4 and 5, not necessarily both, would be really good, since you'll understand how things work in MetaTrader and how Python can then serve those features within your Python environment, allow you to do the same things that you would do inside of MetaTrader. Knowledge of MQL EA functions for this tutorial is optional, since we've done a lot of the work in terms of developing functions, the methodology and the functionality within the MQLEA that's provided open source on our GitHub profile. And we'll discuss elements of that shortly, describing code, structure, everything from functionality and how Python and Python via ZeroMQ talks to MetaTrader. It must be stressed here, though, that Python isn't necessarily the only language that this functionality can be developed in. You are absolutely free to use any programming language that has a compliant binding available in at ZeroMQ, something we discussed in the webinar where we talked about how to interface ZeroMQ, how to interface Python with MetaTrader via ZeroMQ. Some MetaTrader terminology is good to know here. For example, lot sizing, what are magic numbers, ticket numbers, order types, OP sell, OP buy, buy stops, sell stops, etc., that are available to you inside of MetaTrader. In terms of the agenda, we'll discuss one additional ZeroMQ messaging pattern, the publish subscribe messaging pattern that wasn't included in the first segment when we talked about how to interface Python R with MetaTrader via ZeroMQ. Initially, we were using the push-pull pattern and the request-reply pattern. It would be beneficial if you could watch the replay of that webinar first, how to interface Python R with MetaTrader 4, that is available on the Darwinex YouTube channel, and then visit this video for good context and to follow through smoothly. We'll discuss what's new in this implementation. So we've essentially rewritten everything from scratch to serve a few purposes. Firstly, the code has been revised, so it is now in Python 3, as opposed to Python 2.7 that it was essentially in the beginning. MetaTrader 4 side, we have a completely revised expert advisor. In the first webinar, the expert advisor achieved minimal functionality such as to demonstrate how things actually work and how you can build upon it. We received a lot of feedback regarding the same, and we decided to hence actually code up the entire thing and give you everything in terms of functionality, from opening, modifying, closing orders, requesting account summaries, open positions, magic numbers, etc., all communicated between Python and MetaTrader in a standardized format, JSON in this case. So we've done a few upgrades to it. I'll describe shortly. Essentially, at this point, an algorithmic trader using Python or any other ZeroMQ compliant programming language can use the expert advisor as is. However, caution is advised at all times. Please make absolutely sure that everything in the code available to you on GitHub is per your specification, is per your individual requirements. If there's anything missing in terms of code, you are highly encouraged to first read all the code and then move on from there, especially if you plan on using it in a live trading environment. We'll talk about trade execution and management. Basically, following on from what I said earlier, we'll talk about trade execution and management, account and trade reporting, and then we'll talk a bit about what comes up in the segment after this, which will be dedicated to subscribing to market data between Python and MetaTrader 4 via ZeroMQ. Right, so let's begin. Now, this segment will be slightly different from the first webinar where everything was in a PowerPoint. We're actually now going to go into the environments themselves. That's MetaTrader 4, my Python environment, which I use Spider, part of the Anaconda project. And of course, we'll use MetaTrader. So let's get out of presentation mode and go through to the environment. So, in terms of explaining code, we'll start with Python. The script has been completely revised. The script is now called, firstly, DWX-ZeroMQ-Connector. It is available on our GitHub page. Let me quickly go there to show you where that is. And it's on Darwinex Labs. So we'll go over to Darwinex Labs if I can find it. Let's go and do that. There we go. Right. Once you get to Darwinex Labs, the GitHub repository, you head over to Tools, and the new code, both Python and MQL components of the code are in this directory, DWX-ZeroMQ-Connector. Click on that, and you're taken through to the main repo, a main sort of branch here. And the first two lines are important in the sense that the second line really is important. This is where the latest version of any the latest version will always be present here. So this line may change in future and indicate what version we're running on at the moment. You simply need to just visit this page and click here, as it says, to go through to the current version. And at the time of recording this video, the current version is 2.0.1, release candidate 8. On this page, you'll also find a lot more detailed information as opposed to before where we just had the scripts up. So we've done a bit of work here to make things as fluid as possible and as detailed as possible for you to hit the ground running. Our introduction, which is when you have some time over a coffee, you can read through. It discusses what ZeroMQ is, why we need it, what the client server model is that we're going through here and building upon. It talks about, it goes on to talk about installation, the project's, the requirements in terms of libraries and environments. You'll need Python, of course. When it says minimum version 3.6, that is really to say that we developed this script with a minimum of 3.6. We haven't, at this point in time, released any information about backwards compatibility. The code is definitely written for Python 3, but with a little bit of modification. Can, of course, be ported on to Python 2.7 if that is what you're using and for some reason don't wish to tread the waters of Python 3. You'll need libzmq. The minimum version that this implementation was tested on was 4.2.5. This may change in future, of course, with future versions. So there's really no point in me going through all the libraries and their versions. The main libraries you need are the first two, and then PyZMQ, libsodium, open source, available on GitHub, MQL for lib, open source, available on GitHub, and also MQL-ZMQ. The instructions are all provided here. I won't go through them in this tutorial. If you have any questions, you are, of course, free to start an issue if it's a problematic question, or simply email us at info@darwinex.com, and we'll get back to you with additional help as regards these instructions. So, in terms of configuration, I'd like to spend a few moments here. The EA, the expert advisor on the MQL side, as I mentioned earlier, has been completely revised and includes a lot more functionality than before, and hence input parameters. So the first few important input parameters are, of course, the ZeroMQ protocol that we'll be using, which is TCP. Hostname asterisk refers to your local host machine. If you are connecting to a remote machine, you'll need to specify an IP address over here, as well as make sure that the permissions and firewall configuration on the other side allow you to connect to that machine. The push port represents the socket, the push socket that we'll create. The pull port is for the pull socket we'll create, and the pub port This is the new request. This is the new ZeroMQ messaging pattern that we'll talk about in just a second. This is the port for that publisher socket. Millisecond timer, you'll figure this out if you simply go into the event timer code that I'll show you in a second inside the MetaTrader Expert Advisor. This will show you where millisecond timers come into play. And of course, the default magic number, maximum number of orders are 1. So you can, of course, change this to suit your purposes, where the default value is 1. Maximum lot size is set at the moment, for safety reasons, to the minimum, which is 0.01. You can, of course, change this to whatever lot size you would like to execute. Now, one note on the lot size. This script assumes that the lot size is going to be equal to or less than this maximum lot size. So whenever you send trades from Python or any other programming language where you're sending trades to this expert advisor, you need to program things such that they respect this maximum lot size. Otherwise, of course, the trade won't be executed. Maximum slippage, DMA mode is direct market access mode is true. And this last configuration parameter, ZeroMQ configuration publish market data, is by default set to false. The reason for this is that we'll talk about market data, pricing, retrieving data, both historical data as well as real-time bid-ask data from MetaTrader 4 or 5 in the next segment of this ZeroMQ series of webinars and videos. So today we'll set this to false and not delve into that realm until the next video. Here's just what the journal output looks like, experts output looks like when MetaTrader is publishing data, and we'll go through each of these code segments here in a second, and also demonstrate how things work in a live environment. We'll use my Python environment. I've got MetaTrader open, connected to an account, which is a demo account, and the DWX-ZeroMQ server expert advisor, as per the instructions you would have followed when installing and configuring everything, is also successfully loaded on the chart and functioning. Let me take a look at my properties to show you how these look. So they're exactly the same. What I'm doing for the moment, just to demonstrate to you how the retrieving market data bit works very quickly, is I've set it to true. But in the next segment of this series, we'll go into a lot more detail on how this works and storing and manipulating data to for our purposes. So I'm just going to cancel this now, and the expert advisor is loaded. So moving on to the first part of the exercise, sending a trading command from Python to MetaTrader 4. The very first thing we want to do is I want to restart my kernel so that I can show you from scratch everything I'm doing. Kernel will restart in a moment, and then we're going to load the script for execution. Right, there we go. So what you'll notice is a class called DWX-ZeroMQ-Connector, inside of which there are several functions available to you. The functions we'll be covering today will be trade execution specific functions, and I'll show you here how to use them. I will let you peruse the code yourself, and of course there is GitHub with a handy-dandy description of every single function available to you in this script. A note on the way to send orders. So in the Python script, you'll notice that we have a dictionary object that encapsulates information that you'd like to send to MetaTrader 4. It has to be sent in a format that the expert advisor understands, processes, parses, executes, and then sends back a response in JSON format. The default order dict function, generate default order dict function, creates a default dictionary object for you that contains open, specifying open a new trade, type 0, Euro USD, price 0.0, etc., etc., etc. A note on stop losses and take profits. These are specified in points. So when you're developing or incorporating this code in an existing Python or any other trading strategy, then you have to account for the fact that MetaTrader is expecting you to send stop losses and take profits in terms of points and not pips. The order type corresponds to MetaTrader order types, which are OP buy, OP sell, OP buy stop, sell stop, buy limit, sell limit. So this integer value corresponds to the integer value of those order types. And we'll quickly go over there and find those order types so I can show you what these values correspond to. Types of orders, trading principles, buy limit, etc., etc., etc. I think I haven't found the numbers, so I'll find the, let's use an example. So OP by MQL. That will order type. Here we go. These are the order type integer values that MetaTrader is expecting, and these are the only ones that you can hence use from this script. Moving on to actual implementation. So we're going to create ourselves an object. We'll call it ZMQ and create an instance of our class like so. The first messages you get are that it's been initialized and it's ready to send commands to MetaTrader via the push port 32768, and it's listening for responses from MetaTrader via the pull socket 32769. Inside MetaTrader, everything is loaded as is, and it's essentially waiting for us to execute or basically communicate with it, tell it something to do. So go back to Python, and the very first thing we'll do is retrieve that generate order dictionary function that we talked about just now, and see what we're going to be sending MetaTrader by default. So we're asking MetaTrader to open a buy trade on the euro dollar, specifying a price of 0 tells MetaTrader to open a market order with a stop loss of 500 points, which are 50 pips on the euro dollar, take profit of 500 points, which is also 50 pips on the euro dollar, a comment we'd like for MetaTrader to include in the trade, the lot size that we'd like. Now remember, this is 0.01 in this default order dictionary, and you know that in the MetaTrader expert advisor settings, we've also set our max lot size to 0.01. So MetaTrader will not execute a trade if you send it a lot size of greater than 0.01. So for sake of demonstration, we'll stick to 0.01, it's 1 micro lot, and followed by the magic number, which we just set a random number 1, 2, 3, 4, 5, 6, and a ticket number of 0, because ticket numbers are generated by MetaTrader and sent back to you. So we can't generate a ticket number. We can only use an existing ticket number to perform operations on the trade that it corresponds to. So the first thing we'll do here is underscore ZMQ dot I would like to send a trade. If you type DWX, and if you're in IPython console, you'll see all the available functions that start with those characters. In this case, I'd like to execute a new trade. So firstly, we'll just see if any orders are open. Let's have a look at that. To do that, you execute the DWX-MTX get all open trades function, and you'll see that it returns an empty dictionary because in MetaTrader right now, we have no trades in execution. Let's work backwards and test that functionality a bit more. I'm going to randomly execute a trade. This is a demo account, so I'm just randomly buying something on the euro dollar here for 0.01 lots. Now I have a trade open, and that trade has gone into execution. So I can go into my Python environment, enter that same function again, and now MetaTrader tells me that, Python tells me that MetaTrader sent back a response in JSON format with open trades being this only trade here with lot size 0.01, stop loss of 0, TP of 0, and its current PNL. If I want to see what the PNL is after a little while, all I simply need to do is keep executing this trade to get the latest information from MetaTrader. So it's in real time. It will send the instruction to MetaTrader and always get you the actual response. Now that we have access to the ticket number, say I wanted to modify the stop loss and take profit values. When I click buy on this, it said no stop loss and no take profit. So what I need to do here is I need to send an order. I need to send an instruction to MetaTrader that could you please modify the stop losses and take profits on this position, so on this trade. So what we'll do is we'll tell ZMQ underscore ZMQ dot underscore DW what I would like to do is modify a trade by ticket, and you'll see that the ticket number is requested as well as the stop loss and take profit. So here I'll enter this ticket number that I see in the MTX get all open trades, which is 86021149. So 86021149. Of course, in your logic, in your actual trading strategy, all of this can be automated. So you would develop something that reads this inbound dictionary, inbound JSON response from MetaTrader and processes it, and does all of these things accordingly. For sake of demonstration, here I am typing these things in manually, which is very, very inefficient. But for sake of demonstration, it serves its purpose. So we're going to set the stop loss to, let's say I want to set the stop loss to 20 pips. Now remember, MetaTrader is expecting you to specify the stop loss and take profit in terms of points. So we'll enter 200 points, which corresponds to 20 pips on the euro dollar. So remember, the symbol returned is euro dollar, so the euro dollar trade is in execution. And I'd like a 3-to-1 risk reward, reward to risk ratio here. So I'll set a stop loss of 60 pips, which is 600 points. And that's it. So I'll send this instruction by hitting enter. And MetaTrader sends back a response saying that, yep, a modify was executed and 20 pips was set as the stop loss and 60 pips was set as the take profit. MetaTrader on the expert advisor side has calculated the price levels required for this and inserted them into the existing trade. So now you see that the open price of this trade was 1.13513. The new stop loss is 1.13313, which is 20 pips away from the open. And the new take profit is 1.14113, which is 60 pips above the open price on this buy trade. And so now we've been able to execute an order modification, a trade modification. Say for some reason I've made the wrong decision, or for any other reason I want to close this position. Again, all I need to do is quickly have a look at what my trades are just to see what's open, and we see that the same ticket is open. So we'll go through to _ZMQ. Why I just did that is because you may be executing other expert advisors on the account. You may be trading manually. There are several reasons for why you'd want to get all open trades again in your Python environment, just to make sure that the trades you want to close are indeed the ones you want to close. Otherwise, by sending a command like this, you must be absolutely sure that you're doing the right thing, hence the caution. Right, so I'd like to close this order. I can't close it partially because the minimum lot size is 0.01. There's no partial close available here, so what I'll do is I'll close the trade. I have a few options. I can tell MetaTrader to close all the trades. This is dangerous if you are using more than one form of trading on your MetaTrader terminal. So form meaning that you could be trading. Are you trading manually as well as with the ZeroMQ EA that we've provided? Do you have other EAs on the account? Do you have anyone else trading on the account? Are you yourself or your 2-year-old, when you're not looking, trading on the account? There are several things that could be happening. So close all trades is the nuclear option where you tell MetaTrader to close all trades, literally. So we only use that when we're absolutely sure that we want to close all orders on the terminal that are we definitely know about. But in other cases, if you want to play it slightly safer, you can either close all trades by magic number. So say you wanted to close a trade that corresponds to the magic number of the expert advisor here, which is 1, 2, 3. Whoops. Whoa, that was a bad move. Not the right thing to do live on a video, huh? Okay, so we'll just go back to where we were and now have a look at the properties. So the properties here specify 0.01 as the maximum lot size and magic number of 1, 2, 3, 4, 5, 6, as I mentioned earlier. So my other options here are close all trades, the nuclear option, close trades by magic number, and close trades by ticket. Since in this case, I want to close a trade by ticket, I go down to that function, complete it, and enter the ticket number that I'd like to close, which in my case is 86021149. And that will send the order to MetaTrader. MetaTrader will return a response. A successful response will return the actual function, the action performed. In this case, it was, yes, I have closed the trade of order ticket 86021149. The close price I executed the instruction at was 1.13502, and I closed this many lots at market. And the operation was a success. If you don't believe what MetaTrader has sent you, you can, of course, go to MetaTrader and see that the trade is now gone And in the history, that was the last trade that we just closed via Python. You'll notice here that the closing price is 1.13501, but inside MetaTrader, the close price inside Python, the price that was returned to us was 1.13502. This is not necessarily this is not necessarily slippage. This is MetaTrader returning to us the price at which it attempted the instruction, and MetaTrader, once you go inside the terminal, you'll see that it's telling us the price that the trade was actually closed at. This slippage visibly may be due to the latency between the time you sent the instruction and the time it was executed. It may be actual slippage, it may be other things. So what you need to essentially do going forwards is to monitor these things and see where your slippage or latency factors come into play. Right, so we've done a few things now. We've opened a trade. We've checked our account for trades. We want to know what's in execution. We wanted to modify a trade stop loss and take profit. We did that. We also wanted to close a trade by ticket. We did that. We haven't practiced some more trade execution functionality here. So let's go through what we have available. So right, we've got close all trades, close partial by ticket, close trades by magic, close trades by ticket. So let's say we wanted to go the nuclear route. For some reason, we want to close everything on the account. For this to happen, we first need that many trades on the account. So let's go ahead and execute some trades. Let's send a new trade. And by default, it will send the default order dict. When order is set to none, this function defaults to the generate default order dict function, which will open a buy trade on the euro dollar with a stop loss of 500 points, and a take profit of 500 points at a price of 00, which indicates market order. And type 0 is OP_buy, which is a buy order. So we'll do that a few times. That's in execution. So let's go to MetaTrader and see and make sure we've got everything set up correctly. So go to trade, and you'll see that a new trade has indeed gone in, and it has a stop loss of 50 pips, which is 500 points, and a take profit of 50 pips, which is also 500 points. Now I want to do a few more of these so I can execute my nuclear option later. So we'll go ahead and do that. One more. Let's do 5 in total. So we've got 5 0.01 lot size trades in execution, and MetaTrader will have executed all of them. The comments will reveal the DWX Python to empty comment that the default function, the default order dict, also asks MetaTrader to specify. Now we've got 5 orders. All 5 orders have the same magic number, right? Because it's the one EA on the account. So we have 2 options to close all of these. We can say ZMQ._DWX. Close all trades, the nuclear option. Close trades by magic, the semi-nuclear option, which uses the magic number of the EA in question to do that. So what we'll do here is record close trades by magic number. MetaTrader, in its response, returns to us the magic number in this JSON output as well. So we'll use the magic number 1, 2, 3, 4, 5, 6 and say go. MetaTrader will go away, start closing those trades, and then return to you a larger JSON object, which will contain responses to each of the instructions you sent it. So when you send the instruction close all trades to MetaTrader, MetaTrader will then cycle through all the trades and start closing them one by one. Once all those trades have been closed, it will send back to you the status of each closure, whether it was a success or not. And the response. So in this case, all 5 trades that were open have been closed successfully, and the response value is therefore success. So the idea here is to use the expert advisor in meaningful ways, incorporating this code into your existing trading strategy. If you have a trading strategy in Python, you can, of course, the easy route here is to simply incorporate the logic that's been written for you inside this new Python script, DWX-ZeroMQ-Connector version 2.01, release candidate 8, which will change in future as the versions keep increasing. And there are parts of the code that you can recycle. So you don't necessarily have to use the functions that have been written for you. They serve the purpose of demonstrating how this communication happens, this interchange between Python and MetaTrader works. The MetaTrader Expert Advisor will communicate in exactly the same way with any other programming language in which you've developed this functionality. So you don't have to worry about Python being the it of everything. No. ZeroMQ has several compatible bindings. All you need to figure out is which binding supports your program, if there is a binding available for your programming language. Looking at the code really quickly, let's go through the code, skim through the parts that mean something to us. So for instance, I talked a lot about push and pull sockets and publish reports and things like that earlier on. So these are initialized in the onInit function. The publisher socket is bound to the publish report, and this one we're not going to go through too much detail in this video, but the next segment will cover everything about market subscription. Let's quickly have a let's have a quick browse of how that actually works. So a component of this that we'll talk about in depth in the next segment of this series is market subscription, where any symbol that is available inside of MetaTrader 4, data for that symbol you can access through your Python environment here through this Python script by supplying the symbol and actually subscribing to the data in real time. So there are two things we can do here. We can subscribe to the real-time data, or we can collect historical data that's already in the history center in MetaTrader 4 or 5. So for this demonstration, just to show you really quickly how that actually works, I will simply subscribe to the market data and show you how that happens in real time. For that, you have two functions here, sorry. Subscribe market data, unsubscribe all market data requests, and unsubscribe market data. So we'll go through. When you send a market data request, you're actually asking for historical data. But if you'd like to subscribe to real-time data, you need to hit the subscribe market data function, enter the symbol for which you'd like the real-time bid ask information. Don't supply the slash, sorry. And that's it. Subscribe to your USD bid ask updates. Now, when I initialized this class object, this class instance here, I didn't specify my verbosity to true. So here, everything's happening in the background, and there is a variable inside your class instance, your object, called market underscore data underscore DB. This is a dictionary object, the keys of which will tell you which symbols are currently subscribed or were subscribed at some point but have data available in them. Right now, we've only subscribed to one symbol, the euro dollar, so therefore there's one object in there called the euro USD. If I want to see how this is doing, if there is any data, then I simply look at that particular key. And we want euro USD. And that tells us that this data is in here so far. So it keeps updating as the data comes in. You'll notice that the last timestamp is reflective of that. So you can keep collecting data in here. If you wanted to see verbosity, if you wanted to see this verbose output, you'd need to restart your instance with the appropriate variable that's specified in the initializer, which is, it's not specified in the initializer. You have to set the actual verbosity. You can see it in the code later on anyway. But that essentially shows you that you can subscribe to any market symbol that is available inside of, that is quoting inside MetaTrader 4 at the present time. You can, of course, subscribe to more than one symbol as well. So I could subscribe to the euro dollar and the GBP. And now I'm subscribed to both. If I look for the keys now, I have two keys in there. And if I want to see what data has been collected so far, then I can hit that particular key and you'll see that you have a timestamp and the bid ask tuple for each of those data tuples that you have available to you. And that's it. If you want to unsubscribe from any of them, it's just as simple. You use the DWX-MTX unsubscribe all market data requests to get rid of everything. unsubscribe from all the symbols you're subscribed to, or you can unsubscribe from a single symbol. So in this case, for demonstration's sake, we're going to go ahead and unsubscribe from one symbol. That's the first unsubscription that's gone through. And that's the second unsubscription that's gone through. So you'll notice now that your data stops at those timestamps unless there's something still in the pipeline. And yeah, that's the procedure for subscribing to market data. Again, this code demonstrates how to achieve this. This market data DB class variable is set up to store this inbound information to demonstrate how this information looks. You don't have to use the class, the code, in exactly the way it's written. No, you feel free to incorporate this code or incorporate the logic into your existing code. In fact, I encourage you to do so because that boosts creativity. And if you have anything fun and exciting and more efficient to share, please do. We'll always take a look at it. We'll always publish it on GitHub. We'll always reference you in it and give you some exposure as well as feedback as to what you've done and how it's benefited you and will benefit others since it's open source, if it's open source. And on that note, we've covered everything so far in terms of the agenda. We've talked about trade execution and management. So the first thing we did was we executed a trade. We wanted to manage its position because the stop loss and take profit were 0. We sent stops and take profits of 20 and 60 pips respectively to MetaTrader. That was then executed. We then closed the trade. So those were the elements of trade execution and management that I wanted to cover, which is opening, modifying, and closing trades. Account and trade reporting was covered in the sense that you always have the ability with this new expert advisor code as well as the new ZeroMQ bridge script to always obtain your open positions in real time. So whatever's open in MetaTrader, you get it all, and then you manage your positions accordingly depending on your criteria, as I discussed. The criteria being, do you know every single position, every single trade that's open on your terminal? If you do, then going the nuclear options of close all or close all by magic, etc. are safe to use. But if you are trading on an account where there are multiple expert advisors, where you also might be trading manually, you should be particularly careful and use those closure operations by ticket. And at most by magic number. Close all will literally close everything on the terminal that this expert advisor is deployed on. What's next? We discussed and I demonstrated a little bit of this, which is market subscription. We'll cover this in a lot more detail next time. We'll see multi-threaded bid-ask retrieval from MetaTrader into your Python environment. We'll also see how to get historical data efficiently from MetaTrader's History Center. That over ZeroMQ is quite challenging depending on the amount of data that you want. So we have a few other options to use there, and we'll cover both. We'll cover the ZeroMQ option. We'll also cover the flat file read option, both of which will be implemented in Python and shown to you in the next segment. If you'd like to read more about the publisher-subscriber messaging pattern, feel free to go to read the docs, which is over here. Let's go to Pushpull Learning ZeroMQ with pyzmq.readthedocs.io. And over here, you get a description of all the available ZeroMQ messaging patterns, devices, multiprocess, PyZMQ, polling and sockets, and other information. I highly encourage you read these because it gives you a much deeper understanding of how this messaging pattern works and how it's being used in the Python script, as well as in the expert advisor. The publish subscribe one is the new one that is part of this new implementation, the revised code version 2.0.1. We won't talk about it right now. Feel free to read up on it, read the docs, but in the next segment, the next video, we'll be talking specifically about market subscription between Python and MetaTrader 4, and we'll go into this in a lot more detail and cover other options that we can use as well. Thank you very much for putting up with this, and it's been exciting to revise everything to Python 3, to revise functionality, add a lot of functionality to both MetaTrader, the MetaTrader Expert Advisor, as well as the Python script. And we'll see you next time in the next video. If you have any questions whatsoever, please feel free to comment below if this video is on YouTube or anywhere if this video is accompanied by a place where you can post comments. Otherwise, feel free to write to us at info@darwinex.com with any suggestions, feedback, etc. As regards this implementation. If you need any help understanding how the code is structured, feel free again to write us to the email mentioned earlier, or create an issue. If it's a problematic situation, create an issue on GitHub, and we'll deal to it as soon as we can. Thank you very much for your time, and see you next time.